In this video, we will be learning about sections of solids. So in order to understand sections of solid, you want to know the what remember projection of line, projection of a solid, and then only you can understand what remember sections of solids. So in the section of solids, already you have a solid, and for that solid, you are making sections. Your section is nothing but you are taking it a certain height or at a certain distance. You are cutting the objects. Why you need to make the sections of solid is nothing but if the solid is very complex shape and you want to see the hidden lines, what are the hidden lines are there, hidden lines will be visible only if you make a section of a solid. So that's the reason, in order to whenever the hidden lines are confusing to understand the solids, then we'll be mainly using the sections of solids here. Okay, so here orthographic views of solid may contain number of dotted lines, so or hidden lines you have. These hidden details are somewhere in the middle of the object. So if there are more than required number of hidden details, then you can't understand the exact object shape. So that's the reason you have to make sure that if you make any sections of solid, it is easy to draw the object, easy to understand the object shape. Okay. So if there are so many number of lines, suppose it is a hexagonal pyramid, then you have so many number of lines. Suppose this hexagonal pyramid is rotated like this at an angle of theta. Suppose it's rotated. So there are so many number of lines so that you can't understand this shape. So that's the reason what we do, we make the section so that then I can see what is meant by the hexagonal pyramid. I can see the shape of this hexagonal pyramid here. Okay. So this is a shape. It has the hidden lines. A to F is a hidden line. F to E is a hidden line. E to D is a hidden line. And F to O is a hidden line. And O to E is a hidden line. And here you have one more axis line also. So all these lines are a little bit confusing. So that's the reason if I cut here, then directly I can know that what are the hexagon shape is there. I can know the hexagon shape. Okay. So for this reason, we'll be making this hexagon shape like this. Okay. We're making the sections of solids. So we imagine that object is cut by some imaginary cutting plane to understand the internal details. So what are the hidden lines are there? To make the hidden lines visible, we make the sections of solids. Section is nothing but division. So you will be dividing depending upon your requirement, whether it is a equal divisions or unequal divisions. It depends upon the how you want to view the object. You'll be making the sections, equal divisions or unequal divisions. Okay. And even if you cut the object, the observer doesn't know whether it is a cut object or the object itself. Without cutting only, the object shape is like that. So that is the reason to differentiate the cut section and uncut section. What we have to do is, if it is a cut section, compulsory I have to use the hatched lines. So compulsory I have to use this hatched lines in this cut section. Okay. So that's the reason compulsory we have to use this hatched lines here. Okay. Yeah. So hatched lines. So I hope everyone knows the hatched lines. So hatched lines, suppose I have a section like this at the top view, then I have to make an hatching. This hatched lines should be at an angle of 45 degrees with respect to XY line. With respect to the horizontal line, this should make an angle of 45 degrees, and it should have the equal gapping between these two things. Equal gapping, either of, if your object is very large, if you have more area, suppose this is the more area. If you have larger area, then you can take it as 2 to 3 mm. You can take it as 2 to 3 mm is the gap between one hatching and other hatching. You can take 2 to 3 mm. But if it is very small area, you can take 1 or 2 mm. You can take it as the hatching gap. And whenever you are making hatch, this hatch line shouldn't cross the cut portion. It should be within the cut portion, and it shouldn't be shortage of the cut portion. So it compulsory should touch the outer boundary, then only it has to start. Okay. So these are the things you have to remember when when you are solving the problems on sections of solids. So terminology use, you have to know few terminologies. What are these terminologies we are using in sections of solids? So what is nothing but sectional plane. So already we know that what is meant by plane. So you have seen this vertical plane, horizontal plane. So if I say a plane, plane is nothing but a 2D object. Plane is nothing but a 2D object. So suppose if I say but horizontal plane, or suppose I say a vertical plane. So vertical plane will be like this. Suppose I say a horizontal plane. The horizontal plane will be like this. Okay. So there are two types of planes. One is horizontal section plane and one is vertical section plane. So it is an imaginary plane which cut the objects, and whenever the object, this imaginary plane cutting the object, at that intersection point you have to give the numbers, either alphabets or numbers you have to give. Example, you have five sides. It is cutting five sides. Then you have to write PQRST. Suppose it is cutting only four sides of a square prism. You have to write PQRS. Only. Suppose if you are cutting a triangle or any pentagon, only three sides of a pentagon, then you have to write PQR. So like that, you have to make this labeling also. You have to make. So this is a parallel cutting line. So don't write, don't draw the cutting plane as like this. You have to draw it like this. Initially it should be thick, you have to use the HB pencil. Then in between it is a thin, you have to use 2H pencil. And at the end again it is a thick, you have to use HB pencil. Similarly for inclined cutting plane also, there are two cases for the shape. Either I can cut horizontal, or from this axis I can take an angle of 45 degrees and I can cut like this. So there are two types of cutting planes. One is inclined and one other is the horizontal cutting plane you will be having. Okay. And cut surface, it is a surface created due to the cutting of the object by sectional plane. So whenever I cut any of the object, it has the cut section, and for this cut sections compulsory I have to give the hatching lines. So whenever the bottom I have the larger hexagon and top I have the smaller hexagon, example. So all these points are joining with each other with hidden lines also. You can find the hidden lines also, but I'm not drawing the hidden lines. So for showing this cut surface, I have to draw with the hatched. So this is the cut surface I have on the sectional plane. It is shown by the hatching line. You have to compulsory show it by the hatching line. Next are the hatching line. So with respect to XY line, with respect to the reference line, it has to make an angle of 45 degrees, and these hatching lines are parallel to each other. So whatever the line I am drawing, I have to take a 90 degrees and again I have to draw the same. If you fix your drafter at one angle, so same lines you can draw the all the parallel lines you can draw, and the gap should be 2 to 3 mm. It shouldn't cross more than 3 mm. If you are more than 3 mm, then it is a wrong, and the marks will be reduced. Okay. So correct 45 degrees you have to take, and equal spacing you have to take around of 2 to 3 mm you can take. Okay. And here if you see here, the angle is not 45 degrees in this case, and in this case it is reverse, it is 45 degrees, it is negative 45 degrees. Clockwise is negative, so reverse 45 degrees if you're taking, it is also wrong. And here he had taken the exact 30 degrees he has taken, so that is all. So here we are taken with respect to this line, with respect to this line we have to take the 45 degrees we have to take. Okay. And then incorrect representation, if you're not giving the equal spacing, then it is a wrong. If your line is coming outside, it is a wrong. If the line has a short edge, it is a wrong. And if you're giving very much wide spaces, then it is a wrong hatching. If you're giving very too close space like 0.5 mm, then it is a wrong. Even if you're giving 0.5 mm gap also, it is a wrong. Even if you're making, when you're drawing, you two lines are merging together, inconsistency in the line of direction, then it is a wrong. Then then in some, what happens is, your one side of your pencil will be sharp, one side of pencil will be a blunt. Then it is the same pencil only, you're making one line as darker, two lines as darker, one line as small. If you're making all those things, then it is also wrong. It should be equal. It should be thickness should be same, and the gap should be same, everything should be same, then only it is called as the correct hatching procedure. Okay. So these things you have to remember while you are drawing the hatched lines. Okay. And there are two cases. One is plane is perpendicular to VP. Whenever it is perpendicular to VP, automatically it is parallel to HP. These things you have to remember. Either in the problem they say whether it is a parallel to HP or perpendicular VP, both are same. It is also called as horizontal section plane because it is parallel to HP. We called as horizontal section plane. Next, another case is perpendicular to HP. So 90 degrees to HP. Whenever it is 90 degrees to HP, it is parallel to VP. The plane should be parallel to VP. Because it is parallel to VP, we call it as vertical section plane. We can call it as the vertical section plane. Okay. So for this horizontal section plane and vertical section plane, they can ask anything, either perpendicular to VP, horizontal section plane, parallel, plane parallel to HP, both are same. And perpendicular to HP, plane parallel to VP, and vertical section, both are same. Okay. So this is a horizontal section plane. So we say that it is parallel to HP, parallel to horizontal plane, it is parallel. Therefore, it in same height, either the length will be more or less depending upon the shape of the object. Okay. So it is cutting. If you're seeing from the front view, if you're seeing from front view, this edge will project here, this edge will project here, and this edge will project here. Okay. And this is a section. So we already learned how to draw the section line. So first line, dot, line, and this should be darker, and again this is the lighter. Till here it is lighter, and again from here it should be darker. These two things will be darker. Okay. And here we have to write VT because it is on the vertical plane. On the vertical, because for the horizontal section plane, it is perpendicular to VP, and you can just see a line. You can just see a line. So line on VP and complete cut section. So here will be the hatched portion. Wherever it is cutting, here you have to draw the hatched portion, and with respect to this hatched portion, you will be drawing the cutting line. This is my cutting line, and this is my hatched portion. Okay. And similarly, plane parallel to VP. So with respect to this VP, this cutting plane is parallel, section plane or cutting plane is parallel. So you have to draw, this is a plane, and if I make the projection, if I'm seeing from the top view, if I make the projection, this is my line points. So from this point, I have to draw this hatch line. So again, draw a line dot, line dot. So this is my with the darker HB pencil, I have to draw again a line dot, line dot, line dot. So this is my lighter pencil, again line dot, line. So this will be my HB pencil I have to draw, and I have to write HT, and this is my hatched portion. So here I have to hatch. This hatching will be on the VP. So if I project this one, so on VP, the hatch will be there if it is cutting like this. And if it is a horizontal section plane, line will be on VP, and suppose there is a shape here, example a square at an angle of 30 degrees. So for this one, I have to make an hatched portion. Hatched portion will be on, for remember one thing, for the horizontal section plane, hatching portion will be on HP, and for the section plane parallel to VP, then the hatched lines will be on VP, line is on HP. Okay, so these things you have to remember in these sections of solids.